Hello everyone, welcome to this video. In this video, we will be discussing about Docker. Docker it's one of the most popular containerization tool. So what is containerization? Containerization it's nothing but packaging the application and its dependencies into a single container. This container will have the packaged binaries that will include everything the application needs in order to run. As the container has everything, it is highly portable and a self-sufficient unit. All you need is just the container and a container runtime. You can run your application. In the past, we have used virtual machines to run the applications. For instance, when you wanted to deploy your e-commerce application, you have to provision a virtual machine, deploy a web server, and then deploy your web application. It is a time consuming activity, especially if you want to add one more virtual machine to load balance. It is going to take a lot of effort. However, these tasks are very simple with container. Let's compare the container and a virtual machine. Virtual machine needs a full operating system, which means that it need a high amount of resources. However, containers do not need a full operating system. Rather, it just uses the OS kernel, which means that with the limited amount of a resource, you can run your container. Also, as it does not use the full operating system, it will get started immediately. There are so many other benefits are associated with containers compared to a virtual machine. When we talk about the use cases, microservices are highly use the container platform. However, still we use the virtual machine for a legacy application. Docker is one such a tool that help us to do the containerization. However, there are n number of other tools which also supports the containerization. For instance, Containerd, Podman, Vagrant are highly popular tools. Docker uses the layer architecture, which means that you will start with layer 1 and on top of which you will be adding multiple layers. For instance, you will have a Ubuntu layer, and then like on top of which you will be adding Nginx, and on top of which you will be adding your application. In your build machine, let's say if you have an Nginx layer present, then it doesn't really have to download the layer again. Rather, during the build time, it can just reuse the existing layer from the cache. So Docker uses the instructions to define your container image. So some of these instruction will create a new layer and some of these instruction doesn't. For instance, these set of instructions will create a new layer and these set of instruction will not create a new layer. So let's create a Docker file here. This Docker file start from instruction. It says that it will use the Python 3.8 Slim as a base layer, and it will set the work directory as app and copy the requirement.txt file into the working directory, and then it will run the pip installation to do the installation, and it will copy everything into the application directory and set the entry point and a command to run. So as you see here, let's count how many layers it will create. So it will create the first layer, it is going to be the base layer, and the work directory will set the app as a working directory that will create another layer. Copy will create a layer, run will create a layer, another copy will create a layer. These entry point and the CMD will not create a layer, which means that one, two, three, four, 5 layers will get created. So there are multiple ways to improve the Docker file. For instance, here we create the builder image in which we will set it as a work directory, copy the requirement file, do the installation, copy everything else. Now again we create one more from, and the like set is the work directory, copy everything from the builder layer into this particular application and set the entry points. Now if you count here, we will have 1 2 3 layers rather than 5 layers. We will have a 3 layers. So this is what we call it as a multi-stage build, using which we can definitely reduce the number of layers. So let's get started with the hands-on. So first you need to do the Docker desktop. In this case, I would be about the installation on Windows, but the steps are pretty much the same for any other operating system. You need to download your uh, installation package and like do the installation. For Windows, you have to enable the WSL so that the it can use the Ubuntu or a Linux subsystem. Then you can run the command docker version. So as you see here, currently I'm running with version 24.0.6. Then let's see how do we build the docker image and how do we run, list, delete the docker images. So to build the Docker image, you can use. So first of all, you have to define your Docker file. So in this case, this is my Docker file. So as you see here, this uses the base image. I'm copying, I'm setting the working directory, copy everything into the application directory and do the run. So as you see here, 1, 2, 3, 4 layers will get created. I'm not using multi-stage, rather like it is a single stage creation just for a demo purposes. And the like I'm setting the entry point as a Python. Basically it's like running Python and then that particular file in your command prompt. So if you see, if you look into the sample application, just fast API application, so just reads the content, index.html content, and just prints that when you access the application. And then like if you go to the index.html, just it says welcome to fast API. And for the requirement, we will have a fast API and the UVCon. Right, let's go back. Let's build the Docker. So you copy that command, put it here. So it will take a moment to build. So as you see here, it's not actually pulling these layer from the internet, rather like it is just using the existing cache, right? So that's why you see like time spent, it's a 0 0. It's not spending any time. The only place where it spent time, it's like this, right? So that is the beauty of layer architecture. You really don't have to go, and pull this every single time, and then you can run it. Let me copy this command. It says docker run detached mode port 5500 uh, are associated with the container port 5500, and you're calling the docker image my app. Now the application is running, and you can access the application by using this particular port number 5500. Let me do a curl http localhost 5500. So as you see here, I'm getting the response. You can also access the application on your browser. You can use the docker images command to list down all the existing images. If you no longer need the specific image, you can remove that image using this command. So it says that it is in use. So let's see docker ps. Nothing is running. So docker rm that container id, that is done. So just try again docker remove this particular image. Okay, so this is deleted. Now if you do docker images to list the images, it should not list this, so as this is removed. So this is the very fundamental of docker. In the next video we will see how do we use this docker to deploy the application in Azure Kubernetes. Thanks for watching.